Welcome back to the channel, and thank you for being part of this growing learning community. In today's session, we're going to explore how to build powerful multi-agent AI systems using visual programming, a modern no-code approach to designing, orchestrating, and scaling intelligent AI workflows without writing a single line of traditional code. We'll dive into the core concepts of AI orchestration, visual programming, and multi-agent systems, and see how these technologies are transforming the future of AI development for creators, developers, and enterprises alike. Let's begin by understanding what multi-agent AI systems actually are. A multi-agent AI system is a network of intelligent AI agents working together to solve complex tasks more efficiently. Instead of depending on one large model to do everything, each agent is designed for a specific responsibility such as research, logical reasoning, data retrieval, content creation, or decision making. These agents continuously communicate, exchange information, and share results in real time to create a coordinated and accurate final output. This teamwork approach improves speed, flexibility, and scalability in AI applications. Modern multi agent platforms also use visual orchestration tools, allowing developers to build workflows through intuitive drag and drop node graphs instead of writing large amounts of complex code. Imagine trying to control an advanced AI system entirely through thousands of lines of code. As AI workflows become more complex, managing, debugging, and updating that code becomes increasingly difficult and time consuming. This is where visual programming changes the game. Instead of writing everything manually, developers can build AI workflows using simple drag and drop blocks that visually represent each step of the process. Think of it like creating a flow chart for AI. It becomes easier to understand, easier to modify, and much faster to scale. Even beginners, students, and non technical users can quickly build powerful AI systems. Visual programming also improves teamwork by enabling faster collaboration, prototyping, and avoiding coding bottlenecks during development. Think about how AI systems were built in the past. Developers relied on long, rigid scripts filled with hard coded instructions, making workflows difficult to update and scale. As AI became more advanced, frameworks like LangChain introduced structured pipelines, but they still required heavy coding expertise. The major breakthrough came with visual orchestration. Instead of managing complex code, developers could design AI workflows using drag and drop nodes connected like a flowchart. This made AI systems easier to build, understand, debug, and scale. Today, modern AI orchestration platforms act as intelligent control centers where workflows are observable, editable, and deployable in real time, transforming AI development into both an engineering and design discipline. To understand visual AI systems, think of nodes as the building blocks of an intelligent workflow. Each node has a specific job and passes information to the next node through visual connections, almost like a digital flow chart. Some nodes act as trigger nodes, starting workflows automatically when an event, message, or schedule is detected. Tool integration nodes connect the AI system to external APIs, databases, search engines, and software tools, allowing agents to interact with real world data. LLM nodes handle tasks like reasoning, summarization, and content generation using models such as GPT-4 or Claude. Router and logic nodes guide decisions, branching workflows dynamically based on conditions and outcomes. In a multi agent AI system, communication is what keeps everything working together smoothly. Think of each AI agent as a team member passing information to the next person in line. The output from one agent automatically becomes the input for another, creating a seamless workflow. Agents also share contextual prompts, conversation history, and intermediate results so the entire system stays consistent and coordinated. What makes visual AI platforms powerful is their transparent wiring system. You can actually see how information flows between agents, where data changes and where problems occur. This visual debugging approach makes it far easier to trace errors, inspect outputs in real time, and identify bottlenecks compared to traditional code heavy AI pipelines. Think about a multi agent AI system like a professional team working on a big project. Every team member has a specific role and responsibility. At the top, supervisor agents manage the entire workflow, assign tasks, and ensure the final output meets quality standards. Below them, coordinator agents organize communication and keep different parts of the system aligned. Specialist agents focus on specific tasks such as research, writing, coding, or data analysis, using their expertise to solve targeted problems. Tool and data agents connect the system to APIs, databases, and external resources. With conditional logic, agents can even make autonomous decisions, dynamically routing tasks based on real-time information and workflow conditions. In multi-agent AI systems, something fascinating can happen when many agents interact continuously. The system may begin showing unexpected behaviors that were never directly programmed. Think of it like a group discussion where conversations evolve in surprising directions. These emergent behaviors often appear because agents keep responding to each other's outputs, creating feedback loops, conflicting decisions, or accumulating large amounts of context over time. While this can sometimes produce creative and intelligent results, it can also lead to errors or unstable workflows. That is why modern AI systems use real time monitoring, human oversight checkpoints, memory controls, and rate limiting to keep agent behavior stable, reliable, and aligned with the intended workflow objectives. Many people think visual AI workflows are only useful for experimentation, but modern AI orchestration platforms are actually built for large scale production environments. Think of these workflows like modular digital factories that can power real business operations. Developers can deploy workflows as APIs, allowing other applications and software systems to use them instantly. One of the biggest advantages is flexibility. You can replace models like GPT-4 with Claude or even open source models without rebuilding the entire workflow. These systems also integrate directly with CRMs, ERPs, databases, and communication platforms, enabling enterprise-wide automation. This modular and scalable design is what makes visual AI orchestration truly enterprise ready. As we've seen throughout this session, visual programming is transforming the way AI systems are built and managed. Instead of relying on complex code, developers and students can now create intelligent workflows using simple drag and drop nodes. Multi-agent systems allow specialized AI agents to collaborate, share information, and solve complex tasks more efficiently. Structured agent hierarchies, supervisor agents, and conditional logic help create reliable and scalable workflows with built-in quality control. Most importantly, these visual workflows can be deployed as APIs, integrated with business tools, and scaled for real-world enterprise automation. Visual programming is making AI development more accessible than ever before for students, startups, creators, and enterprise teams alike. If you found this video valuable, make sure to like, share, and subscribe to the channel for more educational content on AI, machine learning, and emerging technologies. And stay tuned for the next video.